Okay, so this is the first unit in geometry. It's over the Pythagorean Theorem and the special right triangles. Okay. So the first thing we're going to do is look at that first definition. It says a special right triangle has how many right angles? Anyone want to guess? One. It has one right angle. The side opposite of the right angle is called the hypotenuse. And it's off to the side in that diagram right there. Okay. The hypotenuse is the longest side of the triangle. It's what? The longest side. So right here, this is the hypotenuse. The other two sides are called the legs. Okay. The Pythagorean theorem states that the sum of the square of the legs equal the square of the hypotenuse. This is only true for right triangles. Okay, so can we use the Pythagorean theorem on different triangles that are not right triangles? Nope, it's only for right triangles. And then a right triangle has what angle? How many degrees is a right angle on a right triangle? 90 degrees. So right here, 90 degrees. It's going to be depicted as a little box in the corner. Okay. And then if you recall from middle school when you guys did Pythagorean theorem, okay, the formula is a squared plus b squared equals c squared. A squared plus b squared equals c squared. So let's look at some examples. So on example 1, it gives us which sides of the triangle? The legs. So I'm going to label this leg A and this leg B. Does it matter which one is A and which one is B? No, because we're going to end up adding them together anyway. The only thing that matters is that we label the hypotenuse what? If the legs are A and B, what's the hypotenuse? C. And then remember our formula is a squared plus b squared equals c squared. So if I plug everything in, that is 4 squared plus 3 squared equals c squared. What's 4 squared? 16. What's 9 squared? I just told you. What's 3 squared? 9. So 16 plus 9 gives us 25. So 25 is equal to c squared. How do we find c? Take the square root. So what's the square root of 25? 5. So c is equal to 5. Okay. Any questions? Yes.
When we do that, do we just write the positive one or do we have to do plus or negative 5?
Always the positive one, because when we're talking about triangles, almost think of distance. You can't have a negative distance, only a positive one. So you'd only write the positive. Okay, example 2. What parts of the triangle does it give us? The legs. So this is still A and B. And again, it doesn't matter how you label it. But notice what variable did they put for the hypotenuse? Y. So I'm going to use that variable. A squared plus b squared equals y squared. Then I'm going to plug everything in. So 4 squared plus negative 2 squared is equal to y squared. Why did I put negative 2 in parentheses? Good. So I make sure I square the negative 2, not just the 2, because a negative times a negative is a positive. So we have 16 plus 4 is equal to y squared. So that means y squared equals 20. And how do we get rid of the square? Square root. So y is equal to the square root of 20. Can I leave that as my answer? No, I have to do what to simplify? The prime factor tree. So here we're bringing in some algebra 2 into geometry. So 2 goes into 20 10 times. 2 goes into 10 5 times. We stop there because 5 is prime. Since it's the square root, I'm going to circle groups of 2. And we only have one group of 2. And where is it going to go? On the outside. So this is y is equal to 2 square roots of 5. You will get it marked wrong if you leave your radical as an improper radical, meaning you didn't simplify it completely. So just because we're done with algebra 2 doesn't mean you can forget about it. You're going to see it in geometry. Okay. Any questions on 1 or 2? Okay, number 3. Number 3, what sides of the triangle do they give us? They give us a leg and a hypotenuse. So I'm going to label this one A and this one C. But notice that the other leg is already labeled as what variable? Y. So this is going to be A squared plus Y squared equals C squared. I'm using the variable they already gave us. So A is -5, so this is -5 squared plus Y squared, I don't know the other leg, is equal to 13 squared. Well, what's -5 squared? 25, so 25 plus Y squared is equal to, what's 13 squared? 169. I need to get Y by itself, so what am I going to do? Subtract 25. So I get Y squared equals 144. I take the square root of both sides, and I get Y is equal 12 because it's a perfect square. Any questions on the first half of the notes? So the first half was Pythagorean Theorem. Okay. Now we're going to start talking about angles. Okay. So on a special triangle, it says if a triangle is a 45, 45, 90 triangle, then the triangle is a special right triangle. And what it means by 45, 45, 90 is the degrees on the inside of the triangle. Okay, so here's 45 and here's 45. So the distance between those two lines, the angle, is 45 degrees. And we said that the right angle is what? 90. So that fits with that 45, 45, 90. Okay. So if we have a 45, 45, 90 triangle, we can write the sides in a ratio that looks like this. X, X, X times the square root of X. And what that means is that this is representing the side A, B, and C. So the two legs and the hypotenuse. So if I was just looking at this part here, what does this tell us about the two legs? They're equal to each other. They're both X. So that means they're the same number. And then whatever that number is, we're going to multiply it by the square root of 2, and that's going to give us C, our hypotenuse. So here we don't have to use the Pythagorean theorem if we have a special right triangle. So knowing that, going back to the chart right here, It says, what are the angle measures for A, B, and C? Notice that A, B, and C are in capital letters. If you see it in a capital letter, that represents an angle. Okay? Well, C is on a corner, so we know C is what? 90. And if this is a special triangle, that means A and B have to be 45. Okay, so if this is a special triangle, 45, 45, 90, that means the two legs have to be what? We just said it. The two legs have to be the same. Are they the same? Yep, they're both 1. So that means our hypotenuse, C, is going to be 1 times the square root of 2. Well, what's 1 times the square root of 2? The square root of 2. So I'm going to fill that in here. So the angle A was 45, the angle B was 45, and the angle C was 90. Side A was 1. Side B was 1, and side C, the hypotenuse, is the square root of 2. And that's because we're following the ratio x, square root of 2. Okay. So before we do some of those examples, we got to go back to Algebra 2, and we got to remember the rules of radicals. So this is what we did in, what was it, Unit 11 maybe? Was that radicals? Yeah, Unit 11. So we're going to go through these rules real quick. This should sound familiar. So this first one says, if we have the nth root of a number and we raise that to an exponent of the same root, what happens to them? They cancel each other out. So we're only left with whatever is on the inside. So same n means they cancel. Okay, the next one says if we have the nth root of A times B, so two numbers being multiplied, we could expand this to be the nth root of A times the nth root of B. We can expand it. Okay. Number 3 says if we have the nth root of a fraction, that's the same as giving that nth root to the numerator and the denominator. So these are equivalent statements. Number 4 says if we have the nth root of a number that is being raised to an exponent m, I can take that exponent and put it on the outside. And number 5 says if I'm taking multiple roots of the same thing, so in this case this is the nth root and then the m root, I could take those values, multiply them together, and get my new root. So for example, what if I was doing 2 square roots? What would be this value here?
4.
The 4th root. Okay. Those are our properties. Okay. Any questions on those? Okay. Now we're going to go over here. And again, this is our little refresher from Algebra 2. So remember, if you were doing this unit, you would typically be doing this right when summer is over. So they're assuming that you forgot everything from Algebra 2. That's why they have the little refresher in there. And this part says simplify radicals. So we can't just leave the square root of 72 as the square root of 72. We have to simplify it using what? The prime factor tree. And remember, with that, we always start with 2 until we can't use 2 anymore. So how many times does 2 go into 72? Anybody? I know y'all got your phones. How many times does 2 go into 72? 36 times. How many times does 2 go into 36? 18 times. How many times does 2 go into 18? 9. Can 2 go into 9? Nope, so what would be next? 3. How many times does 3 go into 9? 3, and we stop because 3 is prime. Now, since this is a square root, we're going to circle pairs of 2. So I have a pair of 2 here's and then a pair of 3 here's. A pair of 3 here. From here, what am I going to do with those pairs? Multiply them and put them where? Outside or inside? Outside. So this is 2 times 3, square root of 2, because whatever doesn't have a pair stays inside the radical. So this is equal to 6 square roots of 2. Okay. And I'm going to explain this one other way because I did this in second period and their minds was blown why I didn't say this the first time. But when I taught 8th grade math and we were doing this type of thing, I told them that we know that the pairs go on the outside because you are not allowed to go outside unless you have a buddy. So if you're all alone, you must stay home. Okay, so if you have a buddy, you can go outside. So 2 and 3 have buddies, that's why they're outside. And this 2 is all alone by itself, doesn't have a buddy, must stay inside the house. Next one, number 2, is, again, simplifying those radicals. But for this one, we have to rationalize this fraction because we cannot have what in the denominator? A radical. So how do we get rid of a radical in the denominator? River, how do we get rid of a radical in the denominator? No. Anyone remember how we get rid of a radical? No, not square it. We're going to multiply the top and bottom by the square root of 2. So whatever the radical is, we're going to multiply the top and bottom. So since this is the square root of 2, I'm going to multiply the numerator and the denominator by the square root of 2. So that means this gives me 2 times the square root of 2. And based off the properties of radicals, if I have a square root of 2 times the square root of 2, this becomes the square root of 2 times 2? 4. Okay. So then I can simplify this, and this is 2 square roots of 2 divided by 2 because the square root of 4 is 2. So I'm just kind of showing you why it canceled down there. And then these 2's are going to cancel, and we're left with the square root of 2. So the square root of 2 is our answer. The most simplified version of this without a radical in the denominator. Okay, any questions on those 2 refreshers? Okay, let's do example 1. Okay, example 1. What parts of the triangle do we have? We have a leg. Okay, so let's label this one A. But notice we're missing the other leg and the hypotenuse. So am I able to do the Pythagorean theorem? No. So then I have to go back. Okay, let's see if this is a special triangle. Okay. So this right angle tells me it's how many degrees? 90. This one right here says it's 45. So that means this one on this side also has to be 45 degrees. Okay. Well, since this is a 45, 45, 90-degree triangle, a special triangle, we know that our legs have to be equal. So that means x is going to be equal to what? 13. So we found one. X is equal to 13 because the legs have to be the same. Now, how would we find the hypotenuse? Okay, we could do the Pythagorean theorem, but let's say that is completely off the table. Go back to the ratio, and remember our ratio was x, and what was the last one? X times the square root of 2. And what did we say x was? 13. So that means for y, this is going to be 13 times the square root of 2. So we found x and we found y. Okay, notice because we realized this was a special right triangle, we were able to skip the steps of Pythagorean theorem. So you still would have got the same answer of 13 square roots of 2, but you'd have to do more math to do that. Since this is a special right triangle, we just have to remember the ratio. X square root of 2, representing the two legs and the hypotenuse, to find our answer. Any questions on 1? Okay, last one, number 2. What does it give us? Gives us our hypotenuse. Okay, so this is our C. We don't know our legs, but it does give us an angle of 45, which means this angle is also 45, and it then gives us this angle represented by that little box, which is what? 90. So we have a 45, 45, 90-degree triangle, which means the legs should be equal. So off to the side, I'm going to write that. Okay, I know that x is equal to y. So that means once I find one of the variables, I have the answer to the other. And then the hypotenuse, we know is 30. And we know that the hypotenuse is equal to what ratio? X times the square root of 2. So how would we get x by itself to solve? Do what? So x and the square root of 2 are being multiplied. What's the opposite? Divide. So I'm going to divide both sides by the square root of 2. So this is x is equal to 30 divided by the square root of 2. Is this simplified? No. So what do I have to do to rationalize this? Multiply both by square root of 2. Okay. So I get 30 square roots of 2 divided by the square root of 4, which is equal to 30 square roots of 2 divided by 2. Can I reduce this further? Yeah, 30 divided by 2 is, so I have 15 square roots of 2. This is equal to x. So x is equal to 15 square roots of 2, which means I also know y is equal to what? 15 square roots of 2. Here's our answers.